So next up, we've got Gerard Hamilton. So he's been looking at the effect of charged biochar and compost, the effect of biochar particle size on soil water retention and plant growth of sunflowers. Sorry, that's my fault, not his.
Rightio. So I'm Jarrod, and I looked at the effect of biochar particle size on soil water retention and plant growth of sunflowers. So a bit about biochar to begin with. So the biochar that we used came from grapevine prunings that Frank Stye produced at Terra Preta Developments, and that can have quite a significant impact on what the biochar actually is, because there's things like the manure that can be used, and they can be quite high in things like nitrogen, and other things like woody material can have more structural properties. So the advantages of using biochar, it has potential in carbon sequestration, things like soil water retention, and nutrient value in soils, particularly sandy soils. So we used a couple of soil types, a black clay loam that came from up near the Hort Centre, and a sandy loam that came from the South Arm region of Tasmania. And we thought we'd do that because there might be different particle sizes that are better suited to different soil types. So we looked at 4 different particle sizes and sieved them dry and into the different particle size ranges and applied it at 20 tonnes per hectare. And the mix is a mix of all 4 particle sizes to 25% each. It was done as a factorial design, 12 treatments, 6 replicates, in a glasshouse trial using dripper lines with fertigation applied. And we applied the fertiliser at a full rate initially, and then once they were well established, dropped the rate to half, just to hopefully see the biochar have more of an effect. And we used sunflowers to do that. And the water was applied at 1.6 litres per hour, twice a day for 2 minutes each time that the water was applied. So before I get into the results, there was some major issues with the drippers, likely due to algal growth. So there was quite significant variation within treatments as a result, and largely dictated the results. Even with removing the most severely affected plants, there was still really very limited significant difference between treatments. So first looking at soil water retention, this was done at field capacity. And by field capacity I mean it was either watered manually or by the drippers, and then left for 20 minutes to drain all the excess water out, and then the water retention was measured. So soil type had a significant effect, as you'd expect, with the black clay loam being significantly higher at all the different times it was measured. It gets a lot higher towards the end of the experiment, mainly because the soil wasn't compacted to begin with, and there would have been a lot of root growth right at the end. The 2 readings in the middle are a little bit variable because of the issues with the drippers, so they've probably had some effect on the results as well. So the root growth might have affected some of the end results with the water retention. So looking at the particle size now, similar sorts of trends are found, with it having less of an effect over time. And basically all the treatments were the same at the end. At the start there were some differences, particularly in the smaller particles, and they're all higher than the control, but it became less of an effect over time, so it made it rather redundant. And likely the water retention with the different root growths would have also had a bit of an effect. So looking at the soil carbon, biochar is mostly carbon, so you're going to expect to get more carbon by adding biochar, and they're all applied at the same rate, so there should be roughly similar amounts. The main differences is likely due to the small sample sizes. It was only 20 milligrams in a sample, but quite small samples. But overall they're all higher than the control fairly well. The soil nitrogen, there's 0.05 of a difference really between them all. The control's generally lower than the biochar treatments, so suggests that the biochar that was used had slightly more nitrogen in it than what the soils did, but it's only very minor. The smaller particle sizes tend to have a little bit more nitrogen, but it's only very minor. So onto the plant growth. We looked at several different factors: height, weight, leaf chlorophyll, stem diameter, nodes, flowers, leaf area. None of them were found to have any significant effects, even with removing the most affected plants. Because this is the control without any biochar, and there's things like that one was removed from the data analysis, but it still didn't have effect because there's quite significant variation, because there's roots that were dominant on one side and things like that because of the water limitations that were found in the end. So there's no effect of biochar particle size or soil type as a result, which was slightly disappointing, but is what it is. So in summary, water supply was a major limitation and basically dictated what the results were. There were no effects on plant growth because of that. There were some minor effects on the soil characteristics, but it's difficult to say to what extent because of the water issues. And as a result, pretty much the question that was posed at the start really remains unanswered. So I'd just like to thank these people for their help and support throughout the project to make it all possible. And thanks.
Thanks very much, Jarrod. Has anybody got any questions for Jarrod? So Deepa's asking, what's the motivation behind the study?
There was a lecture last year that had a small bit about biochar, and they said that it increased the growth of plants a lot, so I was just exploring why that was my main. And then Sally had an experiment in biochar, and it's something to learn more about. And, we applied it at the same rates, just at different particle sizes. Yeah.
So Adele was just asking about the quantity and whether that was the same, which it was.
Yep. It was by dry weight basis.
So if you were to extend this study, obviously it didn't quite go to plan, right? That's science, right? So if you were to do it, if it had gone to plan, what would you have done to sort of further that research? What do you think the questions would still be unanswered?
Probably the exact rates, like the exact amount to apply biochar, probably more specific, broader, narrow particle size ranges.
Right, yeah. So
to see what, and the other soil types as well, vary a lot, and different biochar.
Yeah. And, sorry, Doug, you ask. So what Doug was asking is what, from the literature, what did Jarrod expect the biochar to do, and why different particle sizes? Why might that influence water retention?
So basically, the theory behind it is that the smaller particles in sandy soils could increase the water retention because they're smaller than what the sand is itself. Hold more water there, they'll be more available to the plants, they'll be in the range for growing better. Different particles, because of the different soil types, might have different preferences. Say something like heavy clay might want larger particles to let it drain more freely, because if you use small particles, it might block up to waterlogged.
And I've got one last question. Sorry, we will let you go in a minute. If you had found that one of your particle sizes was particularly great, where might this be applied, in what kind of systems?
Could be a range of systems, particularly in poor soils. There's things that are like super sandy or have low nutrients. There could be something like that. A bit variable because some of the literature varies quite a bit. There's quite a range of different biochars that can be used, vary quite a bit in their nutrient properties and their structure. Like manure can be quite high in nitrogen. Other things can be very low in nitrogen value.
Awesome. Thanks very much. Thanks, Jarrod.
Thank you.